Question 12, use the triangle below to answer the following questions. So we want to find angle A, angle B, and then the remaining side AC, just like what we've been doing. So we're going to start with angle A and label the sides. So across from the right angle is the hypotenuse. Across from our reference angle is the opposite. And then we don't know the adjacent side. We'll find it, but not yet. So which trig function has opposite and hypotenuse? That's one we have to use. Sine, right? Sine of our angle equals opposite divided by hypotenuse. We're trying to find angle A, and the opposite length is 7, and the hypotenuse is 17. So to solve for an angle, we take the inverse sine on both sides. We have to get rid of that sine to get A by itself. So once that happens, the sines go away over there. They're opposite, and we're just left with angle A. And then this goes in the calculator. So functions, inverse sine, 7 over 17 is 24.3. And that's degrees. So remember, the two opposite angles in a right triangle add to 90, because that would be 90 as well, right? You could subtract from 180 if you can't remember that. So angle B is 65.7. And this was 24.3. And these are angles, so you have to add degrees. You don't add degrees on a side length. Okay, now let's find the side length. I'm going to call this x, and you can use Pythagorean theorem. I'm going to use trig, and I want this on my numerator because that's the fastest way to solve. So I'm going to use cosine. So cosine of my angle equals adjacent over hypotenuse. If I were to use tangent, it would put my x on the denominator, and it's way easier on the numerator because you just multiply, then it goes in the calculator. So 17 times cosine of 24.3, and we're rounding to 2 decimal places, so 15.49.